Right guys, let's have a look at these then. We're going to do 20 questions here, and this is the first one. I've already in question 0, this is question 1. We're going to do this cubic thing, and what we're going to do is find the turning points, which is the points where the max and mins on the curve, and we're going to do a little curve sketching it whenever possible or whenever convenient. Alright, so this is the bookwork we need, as we mentioned before. This is in question 0. So for a local maximum, we look for this condition to be satisfied. It's an and there. Alright. Okay, so it's divide the x as 0 and the 2y, the second derivative that is negative. If that condition happens, then we've got local max, like a little hill, and then a minimum, divide x as 0, second derivative is positive, and these two things happen, then we've got a local min, and we can put that in our plot. Okay, so let's go back to our problem then and get stuck in straight away to the first problem. So we need divide the x, this is the gradient function. Let's differentiate the line above then. It's going to be 3x squared minus the 2 comes down to be with the 2 to make 4x, the 1 less is 1. The constant goes to 0. So we let that equal 0, don't we? So when does that happen? So here we've got this thing here equals 0. Well, there's an x common in the row, isn't there? So take an x outside a bracket, and there's going to be 2 terms inside. So here's our first line and second line. The first line must give rise to 3x squared. What times x gives 3x squared? Well, you need a 3 and you need an x. That gives 3x squared, yeah? What gives rise when you times by x to minus 4x? Well, you need a minus and the 4. Can you see that? Minus 4x, so that's fine. So this equals 0. So now we've factorized it then. We've pulled out of the row what was common, which was an x, and then we factorized it easily. So in this case, this product is 0 when either this is 0, so there's the first solution then straight away, or this product is 0, and that happens when this value is 0, because 0 times anything is 0 again. So it can happen when this or 3x minus 4 is 0. When does that happen? Well, that happens when, move the 4 over, 3x is 4, doesn't it? Divide by 3 both sides, and you get x equals 4/3. In essence, you're moving the 3 from times on one side to divide on the other. There we are then. There's our 2 places, our 2 x values when this thing equals 0, when the slope is 0. So straight away then, we can draw a little sketch. I'll put the little sketch up here, and we can start putting in the information. The first the input, I'll use the x-axis as an input, and I'll refer to the y-axis typically as the output axis. So you've got input, output. So our inputs are 0 and at 4/3. So the question is, what are the outputs then? So let's tap that into here and find out the outputs, yeah? So let's do that. Okay, so let's put in 0 into here. So we've got y equals x cubed minus 2x squared plus 1, and we're looking at x equals 0. So we get the, I'm just going to overwrite the x with 0 and here as well, yeah? 0 cubed minus 2 times 0 squared plus 1. Sorry about the mess, but that's equal to 1. So the input is 0, the input is 0, the output y is 1. So at 0 we got 1. So I'm marking off that point now. And then the next input is at x equals 4/3. At x equals 4/3. So we've got y equals, well, it's x, I'll put a bracket around it now because I'm going to overwrite it with the value, minus 2 of the x squared plus 1, yeah? And the x is 4/3, so I'll overwrite that now and put that in there. And 4/3 here. So we need to tap that in the calculator. So hopefully, got my calculator here, yeah, there it is. So I need 4/3 cubed, so bracket, 4/3. So 4, then go down, over 3, bracket, oops, delete that. I'll move off the bottom line, back to the fraction and put a bracket, 4/3 cubed, so that would be a power, oops, squared. I need to delete that and put a 3, don't I? Because I should have put a cubed. Back to ground level. 4/3 cubed minus 2 times bracket fraction 4, down below 3, back up, close bracket, and I need that to be squared. Yeah? Because it's 2 times that squared, plus 1. So let's go to plus 1 and equals, and then get SD, a decimal, minus 0.19, because a 5 rounds the 8 up to 9, doesn't it? So minus 0.19. Let's put that there. Let's just have a look at the thing we've written. 4/3 cubed, yeah? 4/3 cubed, minus 2 times 4/3 squared, and that looks good. Plus 1, yeah, everything looks fine. So we're fairly optimistic that's okay. So there's our 2 input outputs then. So input at 0, the output was 1. At the input 4/3, the output was minus 0.19. So I'm going to have to draw it a smidge under the axes here, and that's minus 0.19, isn't it? So is it a max or min? Well, for that, we know they're turning points, so we can draw the 2 possibilities, and we know this one's a max or min, don't we? So let's get the second derivative then, because that will tell us whether they're max or mins, won't it? Second derivative, differentiate this. 3x squared goes to 6x minus 4, because x goes to 1. 4 lots of 1 is 4. So that's equal to then 6x minus 4. The first value is when turning point is at 0. The second turning point when the x is 4/3. So if we put those 2 things down here, and 6x minus 4 and 6x minus 4. The first one we put 0 in for x, don't we? Are all happy that that's minus 4, so that's negative. So max. So we know the one at 0 is a maximum then. So I can do that. And then let's worry about the next one. When x is 4/3, I'll put that in here. Overwrite the x and put 4/3 in a bracket. 6 times 4/3 is 8 minus 4 is 4. And that's positive. Doesn't matter what the value is really. It's positive, so it's a minimum. So when x was 4/3, the second derivative was positive, because it was 6 times 4/3 minus 4, which was 8 minus 4, which is 4, which is positive, so it's a minimum. So here we've got a minimum. So there we are. We can do a quick sketch of our curve then. So I'm not going to turn anywhere else. These are the only 2 turning points. So it's going to turn there, go back up, turn around and go there. And that's it. There's our curve. Let's just tidy it up if we can. Get rid of that thing. Get rid of that. That's better. And then we can label it, can't we? Because it's nice to label. I should have drawn an axis here, which I did, but it just managed to delete it. So this is y equals x cubed minus 2x squared. Oops, squared plus 1. Sorry about that. But there we are. That's question 1 done then. Good. So let's go on to the next one now then. So we start speeding up after this. Okay, good.